So we'll see how this video goes, but I'm thinking this might be the first of 3 videos about exothermic and endothermic reactions. First off, we need to define what these words mean, exothermic and endothermic. The clue is in the word. So exothermic is made of EX, and what words start with EX? Hopefully you're thinking exit, and what do you do with an exit? You go out. Okay, you go out of an exit. Okay, so therm, next word. Next part of the word, therm. Hopefully you're thinking maybe thermal or thermometer. And these words are to do with heat. Okay, so can we put those 2 words together now? Ex and therm, go out, heat. An exothermic reaction is a reaction that gives out heat energy. Okay, same logic now, hopefully for endothermic. Hopefully you're thinking En is enter. What do you do with an entry? You go in, and therm is heat. So an endothermic reaction, a reaction that takes in heat. Right, so if you've been working through these books, you've probably done this practical. We've got two reactions here. We've got hydrochloric acid reacting with magnesium, and we've got water reacting with urea. Now, one of these is going to be exothermic, one of these is going to be endothermic. One of these is going to be a reaction that takes in heat, and one of these is going to be a reaction that gives out heat. So, next question. Next question. Will the endothermic reaction get hot or cold? So an endothermic reaction is a reaction that takes in heat. Will it get hot or cold? Now what you need to do is you need to think about this as if the thermometer is on the outside of the reaction. So the thermometer is measuring the surroundings. It's not actually measuring the reaction. Now, an endothermic reaction takes in heat. So the reaction is going to take in heat from the surroundings. It's going to take in heat from the thermometer. So the thermometer will lose heat, the thermometer will get cold. It will get cold. Endothermic reactions get cold. Exothermic reactions give out heat. If it's giving out heat to the surroundings, the thermometer is going to get hot. Okay, so that's the other thing you have to remember. Okay, so back to this question here. Will endothermic reactions get hot or cold? Cold. Okay. So let's skip past some of those questions there in the interest of time. Okay, if we were to plot a graph of the results of those things, okay, I'm just going to sketch a graph out very quickly. Never sketch graphs in your books. Do them properly, okay, do them properly and measure them out accurately and do them with a ruler and a pencil. But if this graph will have time and temperature like that. Okay, and the idea was to plot both graphs on one axis. So one of those graphs would look a little bit like that, and the other graph might look a little bit like this. Okay, this one here will be the urea and water, and that one there is going to be the hydrochloric acid and magnesium. Right, let's answer some questions. Which reaction went up in temperature and which went down? Well, okay, when answering things like this, we look at the very start of the reaction. So this is the one that went up, that's the hydrochloric acid and magnesium. Okay, HCl, hydrochloric acid and magnesium increased. And the urea and water, urea and H2O decreased. Because we look at the start of the reaction. Okay, this one decreased, it got cold, that's the endothermic. Endothermic gets cold, let's write that there again. Exothermic gets hot, that's right there. Well, the magnesium and acid get hot, the urea and water got cold. Okay, looking at both graphs showing the temperature changes, you can see that the temperature both increases and decreases. What this means is this one here goes up. Okay, the magnesium acid, the temperature increases, but then it starts to decrease over time. Does that suddenly make it exothermic and endothermic? No, it doesn't. Likewise, the urea and water goes down, okay, but then it starts to rise again. Does that make it endothermic and exothermic? No, it doesn't. It just means the reaction finishes here In other words, the reactants have run out there. Okay, you can see by looking at the graphs exactly at what time the reactions finish, when the reactants run out. When that happens, it's like this one here, you've then like got a hot cup of tea, it just simply cools down to room temperature. Okay, you take a glass of cold water out of the fridge, it warms up to room temperature. Okay, they're just returning to room temperature at that point. Okay, so don't be fooled by the fact that the graphs go up and down and up. Okay, you can write the answer down later. What I want to do now is the conclusion. This is the important bit. All right. In exothermic reactions, you would expect to see the temperature, well, exothermic reactions get hot, so the temperature rise. Because energy is being given out to, okay? Exothermic reactions, energy exits, give out to the surroundings. In endothermic reactions, you expect to see the temperature fall. They get cold. Endothermic get cold because energy is taken in from the surroundings. Okay, let's just box that up. Okay, learn. Okay, if you only learn or think about 30 seconds in this video, that's the box to think about. Okay, two other examples of an exothermic reaction. Well, anything you want really that gets hot. Respiration, that's what warms human beings up. Okay, fire, anything burning, that would be petrol burning, fireworks. Okay, literally loads of exothermic reactions. I like putting, when I go skiing, those little sachets in my gloves. When they mix with the oxygen there, they warm up nicely. They keep my hands nice and warm. That's an exothermic reaction. Two other examples of an endothermic reaction. Well, these ice packs, the ice packs, the chemical ones. So they're not full of ice. They're full of two chemicals, and when you use them, you have to break the bag inside the bag, and the chemicals mix and they get cold. Okay, you put that on your poorly knee or whatever, and the energy from the surroundings, i.e. your knee, your swollen knee, your sprained ankle or something like that, the energy from that is taken into the bag where the reaction is happening, and so it cools your leg down. Okay, photosynthesis. Okay, another good example. What else? Frying an egg. Any sort of cooking reaction, frying an egg. Okay, there's 3 there, isn't it? Let's put number 3 next to that. And I think that is the basics of exothermic and endothermic reactions. In the next video, we'll look at explaining the energy changes a little further.